Right, so in this experiment, we're going to have a look at the equilibrium mixture that's got N2O4 in it and NO2. Okay, now in this tube, this test tube, I've got both those gases present, so it is an equilibrium mixture, and you can see it's got that sort of light brown colour to it because there's some of this NO2 gas present in that test tube. There's also some of this N2O4 present in that same test tube. And what I want to do is to look at the effect of temperature on the balance between the two gases. Okay, now to do that, we need to be able to know which direction is exothermic and which direction is endothermic. So I've done that on here anyway. Now, if you remember from our energetics work, endothermic reactions need heat. So the Ford's reaction needs heat to be able to occur. So if I were to put my test tube into some hot water, I would be helping that endothermic reaction, and I might expect that I'd make more of this NO2 gas and see a darker intensity of this brown colour. Now, conversely, if I put my test tube into an ice bath, I will be blocking that endothermic reaction because it needs heat. So the only reaction that can occur should be the backwards reaction, the exothermic direction. So if I were to put my test tube into some cold water, I should see the brown colour gets much lighter as I make more of this N2O4 gas. So let's see this in action. So this is a test tube or one of a set of 3 that's got the mixture in it. This one's at room temperature. Now in these 2 beakers at the side here, I've got 2 more test tubes. They all started the same colour as this one. One's in hot water and one's in the ice bath. So we're going to take them out and compare them to the room temperature mixture. Okay, so this is the hot one. And I think you can see that the colour is darker in that, that tube that's been in the hot water. Okay, if I compare it now with the one that's been in the ice bath, so let's take the room temperature one, pop it alongside the ice bath one. I think you can see again there that this one's got a slightly lighter colour, the one that's in the ice bath. Okay, so it does confirm what I predicted. Stop. Okay, so I want to have a look at the effect of pressure on this equilibrium mixture. So just as we had before with the test tube that had the mixture of the 2 gases in, I've got a vessel here with a mixture of the 2 gases in. This time I've got it in a syringe. Okay, you can see it's got that gingery brown colour, which is from the NO2 that's present, but there's also some of this in the mixture as well, this N2O4. Now the reason I've got it in a syringe is because I want to alter the pressure, so I'm either going to be banging the plunger in on it or pulling the plunger out on it. Now, to make a prediction about what's going to happen, for this one we don't care about whether it's exothermic or endothermic. That's totally unrelated to the pressure. What we're interested in here is the number of moles of gas we've got on either side of our equilibrium mixture. Now here I've got just 1 mole of gas, and I know that because effectively I haven't used a number to balance it in the equation. So there's 1 mole of gas on this side. Over on this side of the equilibrium mixture I've got 2 moles of gas, and I know that because there's a 2 there in front of my formula. So there's clearly more moles of gas on this side of the equilibrium than there are on this side of the equilibrium. Okay. Now what I want to do is to try to increase the pressure on this system in this syringe. And I'm going to do that by pushing the plunger in on it. So the volume will get down much smaller and the pressure will increase. And what will happen is the equilibrium position is going to move in order to try to readjust things so that effectively there's enough room for all the molecules in that mixture. Now 2 moles of gas take up a lot more space than 1 mole of gas, and it's helpful to think of these as balloons. So if you have 1 balloon, that takes up a certain amount of space. If you've got 2 balloons, that's going to take up twice as much space. Okay? So if I try to reduce the volume on it and increase the pressure on it, the equilibrium position is going to move to the side of less moles of gas because that will take up less space. So what I should see is the mixture go more colourless. Now obviously when I push the plunger in initially, I'm squashing all that brown gas into a much smaller volume, so initially we're going to see it look much darker, but then we should see it start to fade. That darkness should start to fade as the equilibrium position itself moves in order that the balance of the mixture in the container is more of this and less of this. Okay, so let's move over here and we'll try to see it in action. So I've got 2 syringes here side by side, so you can see that they're starting at the same colour, and that will help, I hope, to give us a kind of comparison. So what I'm going to do is push the plunger in on this one, and we hope that we see it go darker initially as I squash all that NO2 into a smaller volume, and then we should see it start to lighten again as it's clearly re-establishing that equilibrium mixture. So here we go. So it went darker initially and now it's got lighter again. So it's practically the same colour as the syringe over there. All right, I'll let it expand again and we'll try to see it a second time. Okay, I think they're about the same colour now. So I'll squash it down, we'll see it darker, and then we should see it get lighter again. So it went darker, and I think it's still in the process of just lightening up, and now it looks like it's the same colour as that other syringe again. Okay, we'll try to see it in reverse this time, where I decrease the pressure. So come back to this one a minute for me. So as we decrease the pressure on this, it should mean that there's more space, which should allow more of this to form. Now this one's harder to see with the syringes, but if I pull the plunger out on the syringe, we should see it initially get an awful lot lighter as this brown gas has a lot more space to move around in, so it's effectively a little bit diluted. But then we should start to see it get a little bit darker again as more of this starts to form this, and the equilibrium position moves over to this side, and we start to see it get a little bit darker again because there's physically more space for this brown gas to be available. Okay, so we're going to try it again and do a comparison. All right, this time I'm going to pull the plunger out on this one because it looks like there's slightly less gas in there in the first place. Okay, so we'll use that as our comparator. So to begin with, they're about the same colour. So I pull the plunger out, it gets much lighter, and then it should start to get darker again. It's starting to darken up a little bit, and I think it's almost the same colour as the gas that's in that syringe there. Okay, we can try it a second time. We'll let it go down. It's about the same colour. Ready? Pull the plunger out, gets much lighter, and then you start to see it get darker again, until it's about the same colour as that syringe. Okay.